Good morning. We're going to talk about another way you can solve quadratic equations by using square roots and completing the square. So these will be two additional ways on top of how to use the quadratic formula. So a couple of notes. You can use square roots to solve certain types of quadratic equations, not all. You must first isolate your x variable by moving your integers or your numbers to the other side of the equation. For this method to work, you cannot have a variable raised to the power of 1, meaning you cannot have something that looks like x squared plus, x squared plus x plus 1 equaling 0. You can't have something like this and use square roots. And anytime you're talking about taking a square root, you have to remember that you're taking a plus and a minus version of that number. So this is crucial. If you forget your plus and minus, you are going to get each problem half right because there's two solutions. So let's start here. I should probably put a screen up. So if I start with this, 5x squared minus 30 is equal to 70. I'm going to notice right off the bat I don't have just an x by itself. So when that happens, I can use the square root. Now, you don't have to, but it's usually helpful. So in this situation, what I would first do is I would add 30 to both sides to get that x by itself, so I'm isolating it. So 70 plus 30 is 100. Well, I still haven't isolated my x variable. I notice it's a 5x, so I need to divide by 5. This will leave me with x squared is equal to 20. However, I am not done. I have to take the square root of both sides. When I take the square root of something squared, these cancel. This leaves me with just an x and a plus or minus the square root of 20. But I have to remember that I can simplify the square root of 20 as 2 square roots of 5. So my solutions are actually a plus 2 square roots of 5 and a negative 2 square roots of 5. So this is just another method. Could I have solved this using the quadratic formula? Yeah, my b just would have been 0. So let's work another example. What about this equation? Again, I notice I don't have an x raised to the 1. So when that happens, I can use square root. So I'm going to notice I should probably subtract that 3 from both sides. That'll give me that negative 5x squared equaling a negative 12. Here you might think, my answer is probably going to be an imaginary. However, it's not because this number is negative as well. So when I divide by negative 5, this is going to leave me with x squared is equal to 12 divided by 5. Well, 12 divided by 5 does not come out as an integer. That's an improper fraction. So what I'm going to do is I'm still going to do the exact same thing. I'm going to say plus or minus the square root of that because I'm trying to get rid of this squared. When I do that, this is a little bit tricky. I can split my square roots just like I can when I multiply. So I took the square root of 12 and I knew that the square root of 12 is the same thing as 3 times 4. Well, I actually know the square root of 4, which is 2, and the square root of 3 is just the square root of 3, which is how I got that numerator. And then the square root of 5 is prime, so I just leave it like that. So my two answer solutions are going to be a plus 2 square roots of 3 over the square root of 5 and a negative 2 square roots of 3 over the square root of 5. So let's try another one. What about something like this? It looks tricky. However, anytime I have a fraction, I know I can multiply by its reciprocal. Technically, this is the same thing as dividing by 1/2. But I do want you to start thinking about when I divide by a fraction, it's the same thing as multiplying by its reciprocal. So I multiply both sides by 2. This leaves me with an x minus 1 squared is equal to 16. Now, I want to isolate my x variable. The only way I can do that, I cannot add 1 right now because it's in the square root, or it's in the squared with the x. So I need to take the square root now to get rid of that squared because these live together. These are married by that subtraction sign. So when I do that, I'm left with just what's inside. These cancel, leaving me with a plus or minus the square root of 16. Well, lucky for me, I actually know what the square root of 16 is. Whoops, went too far. The square root of 16 is 4. So I'm going to rewrite this as x minus 1 plus or minus 4. Now, that's not my answer. Now I got to add 1 to both sides. So this leaves me with an x equaling 1 plus or minus 4. So my answers are 1 plus 4, or 5, and 1 minus 4, or negative 3. So those are my solutions. Let's do another one like that. Here, I would do your addition and subtraction first, because otherwise you have to divide that 10 by 3, and I don't want to do that. So kind of do opposite of what you would normally want to do. So I'm going to add that 10 to both sides. That's going to leave me with 3 times x minus 2 squared is equal to 21. Now I'm going to divide both sides by 3. This will leave me with x minus 2 in parentheses, that whole thing squared is equal to 7. From here, because there are parentheses around this x minus 2, I have to take the square root now. So then that leaves me with x minus 2 is equal to a plus or minus square root of 7. 7's prime, so there's nothing I can do. I add 2 to both sides. This leaves me with a 2 plus or minus the square root of 7. So my solutions are 2 plus the square root of 7 and 2 minus the square root of 7. So this is just an additional way you can do solving for quadratics that is separate from the quadratic formula. Now, this method, not a huge fan. It's going to be super rare that you're ever going to have to do it unless I specifically say solve by completing the square. So anytime you complete the square, you have to first make sure that you have no a term. You're going to rewrite that equation with the blanks. You're going to take your b term, divide it by 2, then square it. Add that to the inside of your parentheses, subtract from the outside, factor it, and then solve using the square root method, the method we just used. So if I'm simply remembering how to complete the square, I want to rewrite it saying x squared minus 8x and leaving a blank here. This will allow me to find a factor that will make this a perfect trinomial. So I'm going to say plus 2, and then that blank is equal to 0. From here, I'm going to say negative 8 divided by 2 will give me a negative 4. Negative 4 squared is a plus 16, which means I subtract 16 out here. When I factor this, I know that x minus 4 squared, and negative 4 times a negative 4 will give me a positive 16, and add to make a negative 8. And then this will give me a negative 14 is equal to 0. From here, this is, I've completed the square, and then from here what you would do is you'd solve by using the square root method. I just wanted to remind you how to complete the square. So that's exactly the process we're going to take in these next steps. So can you leave the 1 on the other side? Yes. However, we have talked about completing the square by moving it over. So I've got 0 on one side. Then I'm going to write my parentheses, and I've left my blank here. I went off to the side and said, what's 4 divided by 2? That's 2. What's 2 squared? That's 4. So I put a plus 4 here and a minus 4 here. And then I know that this 2 times 2 will give me 4, and 2 plus 2 gives me 4. So that's how I know this is my factor, and there are 2 of them. And then this negative 1 and this negative 4 gave me a negative 5, saying that, whoops, I went too far. This is my last stage in completing the square. Well, now I want to find the solution. So I want to solve by doing square roots. So I'm going to add 5 to both sides. This will leave me with x plus 2, the quantity squared is equal to 5. I got to take the square root here because it's in parentheses. So this leaves me with an x plus 2 plus or minus the square root of 5. 5's prime. So then I'm going to subtract 2. This gives me a negative 2 plus or minus the square root of 5. So my answers are negative 2 plus the square root of 5, negative 2 minus the square root of 5. Same process here. So go ahead and pause your video, try and do this on your own. And I'm going to reveal the answer. So you should get as your answer negative 3 plus the square root of 10 and negative 3 minus the square root of 10. So what I want you to do now is I want you to work on your IXL specifically for these two sections. Here they are. Remember, your username is your first initial and then your entire last name at WestHS, and then your password is S with that number. Mr. Gillis has those for you if you need a refresher on what your password is. Check your sheet that I printed out for you. After this, you're going to go to an online website called Quiz Is. And this will have extra practice, but this is extra. If you don't get to this, that's okay. But I want these to be at 85% before you move on. So do these to 85% first.